To understand the flowchart concept in a better way, let's see an example. We want to represent the basic process of using a calculator. The first step that we should take is to turn on the calculator, because we can't execute operations without the system starting. In step number 2, we are going to type the first set of numbers. It can be 321, 312, 231, and many other combinations. In step number 3, we select the operation when the first set of numbers is done. The operation can be add, subtract, multiply, or divide. In step number 4, we need to type the second set of numbers, which is needed to execute the operation between numbers. In step number 5, we press the equal button to execute the operation. The calculator will show us the result. The step clear data is not ordered because it is an optional user's decision, so it can be executed after or before any other step. As you can see, we followed a basic flow that doesn't cover the whole situations or use cases. It would be hard to represent them right here. So that's why a flowchart gives us big advantages in creating algorithms. Let's try creating a more detailed flow using a flowchart. If you don't understand the symbolism after this example, don't worry. We will review each component in a future section of this playlist. It is quite simple but very important to start the flowchart with this circle. It means that the flow starts from that point. In other cases, the circle is replaced with a semicircular rectangle. So, the first thing that we need to check is that the calculator is turned on. So, we ask this question: is it on? If the response is false, there is a step or process that needs to be taken to continue the flow, which is turn on, and finally it returns to the beginning. If the response is true, the user will type a number. After typing a number, it will ask if the user will continue typing. If the response is true, we can see that it returns to the process of typing a number and asks again. It is known as a loop. If the response is false, it will store the current set of numbers. The next step asks, is set 2 of numbers finished? If the response is false, the user will select any of the basic operations like multiplying, division, addition, or subtraction. Next, the system will change the first set of numbers to the second one, and after that, the user will type a second set of numbers to operate. At this point, we can see the loop again because after typing a number, it will ask again to continue typing. If the response is true, there is another decision. This step means, do you want to see the result? If the response is false, the system will wait for any other event. I put this because the flowchart can be detailed as much as we want it after this response, but it's a basic example. If the response is true, after pressing the equal button, the calculator will show the results. And the last decision asks, do you want continue? If the response is true, we remember that it is a basic calculator, and for the moment it can't store results and just clears them after every operation is completed to continue operating other sets of numbers. We can see that after clearing results, it returns to the first step, so we can see another loop because it repeats all the flow until it finishes. If the response is false, the user probably will turn off the calculator. And finally, we finished the algorithm with the same circle. Alright, this was a long flowchart, but also very basic, because this flowchart can be more detailed and take more than 3 pages. But we are only representing at a high level how a calculator reacts with a user interaction. At the moment, you only know 4 basic components: terminal, decision, process, and errors. I invite you to create a basic flowchart with the previous components about a task or activity like cooking a burger, buying the supermarket, and more. So if you finish your work, let me know in the comments and I will review your work.